Hello. Today we are going to be doing notes on perimeter of some sort of polygon or shape that you're going to see on a graph. And then we're going to move into area as well. So this week we're going to be talking about perimeter and area of polygons. So we've been graphing linear equations, and some of those have a positive slope or a negative slope. Some have an undefined slope, which would be straight up and down. Some have a zero slope, which would be a straight across line. So we've looked at horizontal lines, vertical lines, and diagonal lines that have slopes, all that are straight and all that are linear. So now we're going to put those together, and we're going to use some of the stuff that we've been talking about to figure out how we find the perimeter of polygons, which is just a bunch of different lines stuck together to make some sort of shape. So the first part of the notes tells us what perimeter is. So perimeter is the length of all the sides that form a boundary of a shape. So if we figure out the length of each side and then we add it up, that'll be what the perimeter is. This first one is pretty simple. It is just a simple square. Now the best part about polygons on the coordinate plane is that you can count the sides because it's on gridded paper, essentially. So each tick mark or each line is 1 unit. So each side is 3 units. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So when we add all that up, it's going to be 12 units. The perimeter of this square is 12. And again, when you're on the coordinate plane, you can count the spaces or units to find the length of horizontal and vertical lines. So if the lines are straight horizontal or straight vertical and they're sitting right on those coordinate plane lines, you can figure out the length of those lines by simply counting the spaces. Those are always super easy, and we go for those first. Now, if your line happens to be diagonal, you have to use the distance formula or the Pythagorean theorem to find the length of that line. And we talked about that last week when we were trying to find distance and midpoint of a line. So you can find the distance of a line or the length of it with our distance formula. So if you happen to have a line that is diagonal and you can't really count the spaces because it's cutting through them in a strange way, you can find the length of that line using the distance formula or the Pythagorean theorem. So let's look at an example together down here. We'll fill this in. I have asked you to find the perimeter of this shape given to us. Over here, I have listed each line segment. So if we look at this perimeter, if we look at this polygon and we're trying to find the perimeter, let's look at each line segment. And again, let me zoom in for you here. Once we zoom in, you can really see the shape. The shape is a strange shape. It almost looks like a rectangle, but this line right here is diagonal. So that's the part that we can't just count the boxes for because it's cutting through them kind of strangely. But other than that, these horizontal and vertical lines, we can just count how many units they are. And we'll have to use the distance formula for this line or the Pythagorean theorem by making our own right triangle off the side. So I'm going to show you how to do that. Let's get this camera going. Here we go. Technical difficulties. Okay, so I have, like I said, I have listed each line segment over here, and what I do is when I'm looking at my shape, I try to find all the straight horizontal and vertical lines, and I'm going to go for those first. So for DG, from point D to point G, this line segment is 1, 2, 3, 4 units long. For DE, this line segment is 1, 2, 3, 4 units long as well. For GF, this line segment is 1, 2, 3, 4, 5, 6 units long. Now the line that's not straight across or straight up and down is EF. So I have two methods here, and I'm going to show you both ways that we could do it. The first way is, if you remember, we can use Pythagorean theorem, which tells us a squared plus b squared equals c squared. And you have this written down on your distance formula notes page. But again, it's a squared plus b squared equals c squared. So what we do in order to do the Pythagorean theorem, anytime there's a diagonal line, you need to come off of it and make a right triangle. So you need to, from those 2 points, you need to meet and make yourself a right triangle, because we know if the lines are straight horizontal or straight vertical, we can count those. So we can make a horizontal and vertical line, we can find those numbers, and we can use those to figure out this one, which is the one we're trying to get to. So if we make this line A and this line B, then we have two numbers to plug in here, and we just have one missing letter. And we know how to solve for a missing variable. You just get it by itself. So it doesn't matter which one you make, A or B. They're both going to go together on one side of the equation, while C is by itself. It'll always be set up that way. So you can choose whichever number to be A and whichever number you want to be B. So I made A 2, and I'm going to make B 4. So when I plug into the formula, it's going to be 2 squared plus 4 squared equals c squared. And that's this side that I'm solving for. So 2 squared is 2 times 2, which is 4. And 4 squared is 4 times 4, which is 16. So if I reduce this line and I bring it down, we now have 4 plus 16 equals c squared. Well, let's start simplifying. What is 4 plus 16? Well, that's 20. So if I combine these two and write 20, go ahead and bring everything down again, equals c squared. This is almost by itself. There's one little thing over here I have to get rid of, and that's a squared. We know to undo a square, you square root. And if you square root one side, you have to square root the other side. So what is the square root of 20? Get a calculator out if you need to, because that's not an exact number. The square root of 20 is 4.47, so we're going to round up to 4.5. So the length of this line, using the Pythagorean theorem, told me it's 4.5. But remember, you can also use the distance formula. So let's look at that possible way of finding this as well. So the distance formula uses 2 points, the end points of your line. So if I'm trying to find line EF, I need to figure out what this point is and what this point is. So I found those ordered pairs, and I wrote them right here for myself. E is 5, 3, so you go over 5, up 3 to get to E. And F is 7, negative 1, so I go over 7, down 1, and I get to F. So using these 2 points as my x1, y1, x2, y2, I plug them in. x2 minus x1 squared plus y2 minus y1 squared. And all of that is under the square root sign. So now we just start simplifying what we can. So 7 minus 5 is 2. So that's going to be 2 squared. Plus negative 1 minus 3 is negative 4. Remember, same signs, add them together. Now let's square them. 2 squared is 4. Again, look, this looks very familiar to where we were up here. Negative 4 squared is negative 4 times negative 4, which is positive 16. Two negatives multiplied together make a positive. And 4 plus 16 is 20. And what is the square root of 20? We have to simplify this. 4.5. We just checked it out on the calculator. Both ways work, whichever way you prefer. So when you see something that has a diagonal line, you can either find the ordered pair for these 2 points and use distance formula to find the length of that line, or you can make a right triangle off of that diagonal line and solve for the missing side in that triangle. I will tell you personally, I do this method a lot versus the distance formula. They both work though, so that's totally fine as well. So we're going to fill this in. The answer that we got for EF was 4.5. So the perimeter is going to be whatever all these are added up. So let's add them up. 4 plus 4 is 8, plus 6 is 14, plus 4.5 is going to get us to 18.5 is the perimeter of the shape. And now on the next page I have two more examples just to go through real quick. Okay, here's our first example. Find the perimeter of the polygon below. So again, I labeled all the points A, B, C, D, E, and F. And I wrote each line segment over here to the side. When I did this, I started with line segments that I could see were horizontal or vertical. So I didn't start with AB because I wanted to work that one out down here. And I didn't start with BC, but I did see that AF is a straight horizontal line. FE is a straight vertical line. ED is a straight horizontal line. And CD is also a straight vertical line. So these four, we can just count those. Those are super simple to figure out how long they are. So AF is 1, 2, 3, 4 units long. FE is 1, 2, 3 units long. ED is 2, 1, 2. And CD is 1, 2, 3, 4, 5, 6. So those are super simple to figure out. Now AB is again a diagonal line that we can't just count the squares because it's not going exactly through them, nice and evenly. So we have to use either the distance formula by plugging in these 2 points or Pythagorean theorem. And again, remember, I typically use Pythagorean theorem. So let's zoom in so you can see my math here. What I did was I made right triangles. So from this point to this point, I just came out and made a perfect right triangle on the outside of my shape, making that diagonal my hypotenuse, or my longest side in my triangle. So if we know a squared plus b squared is c squared, this is the c that I'm solving for every time. These two sides will always be together in the equation. They will be set equal to the side I'm looking for, to c. So the side you're missing is always going to be c. So I made this my a, and this my b, and the c is what we don't know. So 5 squared plus 3 squared equals c squared. So what is 5 squared, or 5 times 5? 25. What is 3 squared, or 3 times 3? 9. And what is 25 plus 9? 34. And then to get this by itself, to undo the squared that we see, we have to square root, because those will cancel each other, leaving the c. But if you do it to one side, you have to do it to the other. So the square root of 34 is 5.8. So that's going to be the length of AB, 5.8. Now the other one we have is BC. So I made a right triangle on the outside of this shape to where the diagonal I'm looking for ended up being my hypotenuse, or the side that I don't know. So these two numbers that I do know, I counted. This is 3 units long. This is 2. So I use those as my A and my B. So again, right here, BC, I'm going to use the Pythagorean theorem. 3 squared plus 2 squared equals c squared. So what is 3 squared? 9. What is 2 squared? 4. 3 times 3 is 9. 2 times 2 is 4. What's 9 plus 4? 13. And to get c completely by itself, again, at this point, once we plug these numbers in, we just simplified them and combined like terms. So there's nothing else you can do on this side. And you just got to keep bringing this down. And if the goal is to get c by itself, there's never any reason why these numbers need to be moved over. The only thing that has to go away on this side, at the very end, is our squared. So to undo squared, we square root. And if we square root one side, we have to square root the other side. So the square root of 13 is 3.6. So the perimeter, the perimeter is simply going to be all of these sides added up together. So we have 4 plus 3 plus 2 plus 6 plus 5.8 plus 3.6. So our perimeter is 24.4 units. That's how long all the sides are when you add them up together. And here's the very last one. And we'll be done with this video. I know it's a little bit longer, but I want to make sure we understand how to get these perimeters when we're using Pythagorean theorem. All right, find the perimeter of the polygon below. So, again, there's lots of sides here happening, lots of them. Each line is going to represent one number. So when I look at my polygon, I listed out all of the straight horizontal and vertical lines first. As you can see, there's only one diagonal line that doesn't cut straight through these lines up and down or side to side, and that is DE. So you have the option of, from those 2 points, coming out and making a right triangle, right? Counting the length of this side, the length of this side, and doing Pythagorean theorem. Or you can use the distance formula. So for this example, I did use the distance formula because the example above, I used the Pythagorean theorem. So you can look at both of these examples. Both methods are right, but you may prefer one over the other. So let's find the perimeter of this polygon below. So AB, we're going to count the length of this line by just counting the tick marks. 1, 2, 3, 4, 5, 6, 7. 7. BC, so that's from point B to point C, is 1, 2, 3, 4, 5, 6, 7, 8. CD, 1, 2, 3, 4, 5, 6. FE, 1, 2, 3, 4, 5, 6, 7, 8. AF is the very last straight line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's a very long line. And then DE is diagonal. So I can't just count how many squares it crosses because it's not going straight up and down or straight side to side. So I'm going to use the distance formula, which we know to be x2 minus x1 squared plus y2 minus y1 squared, and all under the square root sign. So I found the points for E and D. The ordered pair for E is 4, -8. The ordered pair for D is 9, -3. So those are the 2 points. So I can use those 2 endpoints to find the distance of this line using the distance formula. So I plugged in the numbers in the correct spot. x2 minus x1 squared plus y2 minus y1 squared. Please note that y2 minus y1 is represented properly here. I have minus the negative number. You wouldn't just put -3 minus 8. The formula says y2, which is -3, minus y1. So even if y1 is negative number, it doesn't mean that this minus does not go here. It always does. So what is, get your calculators handy or your phone or whatever it is that you might be using to help you do this math. If you're doing it in your head, that's great. What is 9 minus 4? It's going to give you 5. So again, when you rewrite this, all we're doing is simplifying, and we're simplifying in a certain order. If there's anything in parentheses that can be combined, you need to combine that first. So we're going to combine these numbers, then we will do exponents, PEMDAS. Then we will combine those two together and figure out what the square root of them together, what that is. So 9 minus 4 is 5. And -3 minus -8, well, these two negatives become plus a positive. So that's actually going to be 5, right? And you can use your calculator if that's confusing, but what I like to say is 2 negatives together make a positive, right? So it becomes plus a positive. So at this point, they have different signs. So I say, what's the difference in the numbers? The difference between 3 and 8 is 5. And because this is now a positive and it's bigger, the answer will be positive. It always takes the sign of the bigger number. So what is 5 squared? Well, 5 times 5 is 25. And same thing over here, 5 squared or 5 times 5 is 25. Well, 25 plus 25 is 50. So at this point, all you have to do is say, well, what is the square root of 50? And it is 7.07. So you can round that up to 7.1 if you'd like to. Now, if you had chosen to do it the Pythagorean theorem way, I'll show you right over here, really small. That still works too. Let's count the length of these two sides and figure out what this diagonal line's length is through the Pythagorean theorem. So this is 1, 2, 3, oh gosh, 1, 2. I started connecting my dots and not the lines. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Also 5. That got a little messy there for a second. Okay, so it's going to be 5 squared plus 5 squared equals c squared. And if you notice, we had something just like that here. And at the end, we're going to have to square root this to cancel that out. And do you notice how this is all under square root? So we're going to get the same thing, it looks like. 5 squared is 25. So let's go ahead and simplify that number and then combine like terms, which becomes 50. Bring everything else down. If I'm trying to get c by itself, the last thing I have to do is square root both sides. The square root of 50, we just said over here, is 7.1 or 7.07. So the length of this last line is 7.1, meaning our total perimeter, when we add all these numbers up in a calculator, 7 plus 8 plus 6 plus 8 plus 13 plus 7.1 is 49.1. Great job. If this video was too confusing and you still need more practice or more examples, you can always go to Khan Academy. That's Khan Academy, and they have tons of videos, and you can just type in perimeter of polygons. You can also go to YouTube and just search perimeter of polygons, and tons of videos will come up if this one was not helpful. But good job taking your notes today and following along with this video. If you didn't print them out and fill them in as we went and you wrote them on your own, thank you for doing that as well. Make sure that you watch this and you fully understand so that when we get started with our work in class, we can just jump right into it. Thanks, guys.